So, hi, my name is Alejandra Martinez. We are group members 2. We're engineering technology majors. So the product that we're trying to produce is a multifunctional cube. The purpose of the cube is to ensure that it serves all purpose in regards to office space. So it's going to include like a sharpener, charging station, along with a timer. So that's going to be the total functionality. So ensuring that we meet lean manufacturing standards. We're ensuring that our product does not produce any form of defects in 3D printing within SolidWorks, along within wiring components. So we're going to be breaking that down within each station, so that way you have an understanding of how it works. We can transition on to our first station.
My name is Oscar Navarez. I do the first station. I'm in charge of design for the SolidWorks. So my purpose on this one was to make sure that we follow all the manufacturing standards, such as CAPA and stuff, and making sure we reduce as much waste as possible when going through our designs. Less bigger pieces, more space and stuff.
Okay, hello, my name is Derek Lopez. I'm a third-year engineering technology major here at Cal State LA. So for my workstation, I 3D printed the multifunctional cube. So based off the SolidWorks design, we printed both the top and the bottom as well, and the housing for the clock and the sharpener. And it's basically, it has a filament of basic PLA filament in it.
Hi, my name is Beverly. I'm an engineering technology major, and I'm in charge of workstation 3, which includes the soldering of the alarm clock. So this is a 4-bit electronic clock, and it came with a kit with 16 electronic components. And something we had to consider was to make sure that the polarity was right for the components. So the soldering was to ensure to implement Poka-yoke, which eliminates errors so that the components don't come off, so that they're secured in place. And this is placed here. Oscar and Derek designed and printed the housing of the clock. And I'm gonna pass it on to Dino.
What's up? My name is Dino Villacorte, and I'm a third-year student here majoring in engineering technology, and I worked on the housing for this one, in which I will drill the holes for each screw to go into the lid, which will house the wireless charger, and also focused on the like the casing for the clock, as you can see right here, as it slides in like that. And also what I worked on was implementing Poka-yoke strategies into this design process, in which, like Beverly said, would eliminate all types of waste. In this case would be weighting and transportation, and also implemented the 5S strategy to set all equipment in an orderly fashion. And so for this one, this drill right here, I drilled it according to the size of 29 drill bits, and also used the tap drill, in which I utilize this tool right here to further widen the hole, so each screw can go in. And the screw that we're dealing with is this one right here, this little screw right here. And also worked on the placing in the pencil sharpener, as you can see right here. Slides right in like a beauty. Which Amy will take care of.
Hi, my name is Amy Fainsa. I'm an ETEC major. I worked on the splicing of the wiring of this portion. So ultimately, we began with the design of individually plugging in each electrical component into its designated USB port. But ultimately, because of the compact design and due to just cleaning up the entire design, we decided to splice the wires into one, so that way we have one electrical component. Some methods that could be used to speed this process up would be to use Kanban to signify with the wire and connector supply. Also, color coding the wires would have helped a lot more to create a more efficient workspace as well as improve lead times. But ultimately, it reduced waste by not requiring excessive materials such as charging blocks. So that is where we are with the wiring, and I will pass this on to our workstation 6.
So within workstation 6, basically we will be applying Hajunka. So this is basically addressing the setup time. So this is ensuring that this station has its appropriate toolbox. So that means its appropriate screws and wrenches. That way it's able to complete the assembly process a lot quicker when trying to install the screws. As you can see here, as Amy mentioned, we would also try to apply color coding the wires. That way it's easier to establish what type of connections connect to where within our electrical components, such as this cable. This connects to our wireless charger. So having color coding these cables will make it more efficient to connect the wires to its appropriate slot. That way it's able to establish a good connection with within our electrical components. And then assembling all parts of the multifunctional cube. So that includes the top, the body, and the bottom or the base of the multifunctional cube. After that is installed, we ensure that the screws are drilled in. So this is where we apply Hajunka, so having the toolbox ready. And then we'll transition on to workstation 7.
Hi, I'm Aries Romero, third year engineering technology student. I am workstation 7, which is quality control, to identify any defects that we have in our product and to make sure that it's up to our customer standards so that we're not giving them a piece that doesn't fit their requirements. For me, I would have to really look through the different screws to make sure it's in place and sturdy. Make sure that the wireless charger is not wobbling and that it's plugged in and actually works. I'll check out the splicing, the soldering and plugging it in so that it does verify that it is functional. Thank you. And then once I inspect it and say that it's good to be passed on, I'd pass it on to workstation 8.
Hi, my name is Kenny Lee. I'm a third year majoring in engineering technology. And this is workstation 8. Workstation 8 is about packaging and shipping. And in this workstation, I pack the product to make sure that it's safe and ship it to make sure that it gets delivered to its desired location. Some lean methods that we can use is Kanban cards to tell my suppliers I've run out of boxes, like right now. And also I can apply the 5S, namely sustain, to make sure that the quality is kept during the shipping process, to make sure that the quality here is the same quality as it is when it gets to its desired location.
My name is Oscar Alvarez, and for workstation 1, at least for assembly, my job was to basically, on the SolidWorks, check if anything collided with any of the other pieces, making sure that there was no other issues such as one being too big, centralized in every size, and that's it. Making all 4 pieces, make sure they all fit together.
How long was your workstation?
Oh, it took me about 3 hours to design everything all together. About one hour for the center sleeve, 30 minutes for the top sleeve, 30 minutes for the, not 30 minutes for the top sleeve, 30 minutes for the top lid, 30 minutes for the bottom lid, as well as ensuring that the clock base, which we do have right here in the front, fit properly to ensure that the clock would not slip out during any building.
Hello, my name is Derek Lopez, and for my workstation, we went through the 3D printing process. So through this, I had to change the quality, the strength, the speed, and the support, just depending on each part. And it also, this through Bamboo Studio, it gave me an estimated time of each part. But since we used 3 bamboo printers at the same time, and one of them being the home for the sharpener and the entire box, it took about 5 hours and 31 minutes just to basically print out our entire product. And I'm passing it to Cece.
My name is Beverly Blue, and I was in charge of the alarm clock. So the soldering took about an hour total, which was mostly ensuring that the pins in the back were isolated so it wouldn't mess with the circuit flow. And one issue we ran into was that the network resistor, which is that one right there, it was in the wrong orientation, so we had to undo it. And the way we did that was by using a desoldering wick, and that took about another 10 minutes to undo it and fix the orientation. And this would be placed right here. I'm gonna pass it on to Dino.
So, name is Dino Vilcordi, and what I helped out on was I spent the most time on was doing the drill bits, in which I used a 29 drill bit to drill holes into each of the corners of the top plate, not the bottom plate, since we didn't want any hassle for the consumer to unscrew some screws when emptying out the pencil shaving tray. So using a dial caliper and a tapped hole to further extrude the sizes of each hole for the body sleeve, as you can see right here, we were able to drill the holes into their precise sizes. So if you follow the righty-tighty, lefty-loosey method, you will be able to tighten these holes to a good extent. So yeah, for the timing, it would take around 20 minutes to get the sizes of each of the holes and drill them and use the tapped hole to further extrude them and assemble. Yes. And off to Amy for workstation number 5.
So, with station number 5, as you can see from here, my job is to splice the wires of all electrical components, and while it's taped currently, the goal is to solder each wire individually to ensure the safety of each electrical component. But ultimately this was chosen to reduce the amount of wires and clean up the product. That way the consumer only has to worry about one outlet to plug into rather than multiple. So as you can see here, each wire was individually connected. And this approximately took around 30 minutes. And I will pass this on to the assembly station.
And basically what we're doing now is adding all the electrical components, making sure they're all connected. The clock is already connected, so next thing we're going to do is put the cables through their appropriate socket to make sure that they're able to connect. So this one is for the lamp, so we're going to be clamping it here. And then this one is for the wireless charger. And then the lamp, making sure it clamps here. And it connects. And then we add in the drills to make sure that the screws in. That way we ensure that the top part of the clock doesn't move. And then we added Velcro to ensure that the top part wouldn't fall off when trying to take off the pencil shavings when in use. So essentially, that's, you take that off and then place it. This is well drilled in, and then it goes into workstation 7.
Where I have for quality control, I'm Aries, and this is where we identify any defects and make sure it's up to standards. So if we're talking about this specific one, the screws aren't tightened enough, so that will slide out easily, and the Velcro needs to be finished opening, but other than that, the clock placement is good, and the clock placement is good, and the wireless charger plus this is well. If this was up to standards, we'd process it through packaging. If not, we take it back and say stop production to figure out where the mistakes were made.
Workstation.
It took around 10 to 15 minutes.
This is workstation 8. In this workstation, we pack the product and ship it. So we pack it so it is secure, so the product doesn't get damaged during shipping. Something like this. So in this package, we would have stuff that keeps the product in place so it doesn't move around too much, to make sure it's secure, doesn't get damaged in shipping. And we send it off, we tape it up, we put a sticker to make sure the product gets sent to our customer, the right customer.